So today I really wanted to talk about practical generative AI. I saw a few of the sessions over the week, and there's been a lot of different facets of generative AI. There's been the traditional machine learning, big data. There's been a lot around generative AI because of how popular it is. I work with generative AI every day, so that's what we're going to be talking about. Specifically, my experience over the past couple of years has been building generative AI applications. So the reason for that is 2 years ago I started working with a venture studio right as ChatGPT got really popular, and we said, hey, we need to launch a bunch of companies. Let's do it with generative AI. So we've been doing that for the past couple of years. All right, human in the loop. That is one of the main topics of this conference, obviously. And so the focus for today is how do you build a system keeping humans involved and making them as efficient as possible in the decision-making journey. Before we do that, I am very, very curious, how many of you have not heard of ChatGPT? Not heard of, how many of you have not heard of it? Perfect. All right. I want just a show of hands, how many of you have used a chat engine besides ChatGPT, besides Perplexity? All right, pretty good, besides Claude. All right, we're still doing good. And how many of you could name more than 3 models, not applications, generative AI models? All right, so we went down there, but I'm actually still really impressed. What I mean by that, by the way, is ChatGPT is powered by OpenAI's 4.0 model, and sometimes you can use the 0.1 or 0.3 models, but the models are different than the actual applications itself. Okay, so what are we going to talk about today? Obviously, we're talking about a lot of generative AI, but I want to start with talking about why generative AI is different than traditional software, and why you need to build traditional software or systems differently if they incorporate generative AI. Then we're going to talk about how to incorporate humans in the loop, what the design patterns are. But we're going to start with design principles. And once again, my goal here is for all of you as technology users or adopters or builders to be able to come away with some really practical ways of knowing how to use generative AI systems in a safe, efficient, and human-assisted way. And then lastly, we're actually going to walk through a lot of designed patterns using some case studies. And these case studies are applications that are out there right now. They're being used, and they are built on generative AI. So once again, the goal here is to be as practical as possible. We're going to try not to be very theoretical. We're going to try and use as many real-world examples as we can. All right, so first off, we're not going to spend a lot of time on this because all of you seem to be familiar with generative AI, which is great. But the interesting thing about it is, 2.5 years ago, I would venture to say that of the companies here on the left, most of you would probably recognize one of them, which is Meta. And by show of hands, I could ask that, but the interesting thing is, the very bottom one, that M is called Mistral. It's a French company. That one didn't exist. So this is extremely new. It's cutting edge, and it has brought a lot of possibilities that didn't exist beforehand. These are really some of the things that generative AI presents that has captivated everybody's imagination and the use cases in technology. First off, accessibility. For the first time, we have an input modality where you can interact with software the same way I'm speaking to you. And beforehand, that was an exceptionally hard problem in software development. To build software, to build systems, you had to understand programming. You had to understand how computers think. This is the first time that you can talk to a computer and it can translate human speech in such a way that it can act upon it. So it's extremely accessible. But it also unlocks data formats that previously couldn't be used in a system. By show of hands, how many of you struggle because you've got some data in your company that's in a PDF and it's not text-based? Yeah, PDFs are the worst. The AV guy, that makes me happy. In setting up this conference, he probably had that problem. But generative AI allows you to deal with text, which is what you could consider unstructured data. It's not an Excel file. It's not a database. It's just text. And previously, you couldn't deal with that in any way, shape, or form. But generative AI lets you do that. And then because of all of these capabilities, you have tasks that previously required a human, but now they don't. Now you can either assist that task with software, or you could replace it. And for me, the exciting thing would be never to have to read another PDF ever again. I would love that. And then finally, the speed of innovation in this landscape right now can't be overstated. Whatever you think is going to be possible in 6 months is probably going to be faster than that, and I don't think anybody knows what this landscape is going to look like in 12 months because it has progressed so quickly. How many of you have seen the news articles about DeepSeek? I'm impressed. That makes sense. Nobody knew what DeepSeek was a month ago, but the interesting thing was they released the foundation model a month ago, and R1, which is the one that has just made headlines, is just a reinforced learned version of that model. So it's evolving extremely quickly, and that's great for anybody who wants to be able to take advantage of these opportunities. Okay, why is generative AI different? Well, if you think about traditional software, think about any application you use, and application can be a website, can be a mobile app, can be a computer program. They are consistent, they're traceable, they're deterministic, and they're easy to test. What I mean by that is traditional software function. I've got an input. If I put that input in, I'm going to get the same output. If I run it 1,000 times, 1,000,000 times, I'm going to get the same one, unless it's designed to produce different results, but for the most part, software is not. It's also traceable. I can know exactly what path that took through my code, and I can understand why it came to a decision. It's deterministic, which is similar to consistent, a little bit different. Deterministic means that I know every time, based on this input, I'm going to get a certain output. There's no variability within it. And then lastly, it is easy to test. Mostly because we've designed it to be easy to test. And if I have any QA engineers in here, they're probably going to disagree with this, but work with me here. It's meant to be easy to test, okay? Generative AI is fundamentally different for a lot of reasons. One, it's inconsistent. And that variability is built into the architecture of these models. Yes, I know you can set the temperature of a model to 0, and you're going to get less variability, but it is not deterministic. And they are built not to be deterministic. They're difficult to trace, and there are a few reasons for this, okay? The primary reason for this is that these language models, LLM stands for large language models, these are impossibly large. Let's take Meta's flagship model, or their most powerful model, which is Llama 405. That means that it has 405 billion parameters. So if you want to see why a particular input produces a particular output, you would have to trace 405 billion parameters through multiple levels to understand which numbers were activated to give you a prediction on what should come next. And that's really hard to do. Even with computers, it's really hard to do. Anthropic is actually trying to do it a bit. They've made some progress, but it's very difficult to do. And so it's difficult to test. The reason it's difficult to test is a lot of the tasks that these models are meant to do are a little bit more subjective than objective. And so people don't approach them in the same way that they would traditional software development, where they would say, okay, well, here's my scenario. I expect to put in this, and I expect to get out this. Now, if more people thought that way, actually the software would be better, and we're going to talk about that. But for the most part, that's not how people think about these models. And I think the main reason for that is the primary interface is chatbots. And it's really difficult to know what should a chatbot respond given a particular message. The same way, like, what would a human respond? It's most akin to walking the streets of New York City or something with a poll question and seeing what kinds of answers you get. They're going to be very highly variable. And then what I mean by this is just it's not just that it's a black box. When you use an application that uses generative AI, typically the way it produces its output is completely magic. It's a black box. You have no insight into what information is it looking at. Is it using its internal training? Is it using the context you're giving it? And that makes it extremely difficult to use it with highly important tasks. Okay, so what are some risk mitigations when you're using generative AI applications? These are the ones that we're going to talk about, or that come to mind immediately. And the first is just system design, okay? The prompt has a huge impact on this. The data that you provide it has a huge impact in it. And I would say all of that is table stakes. Most people, when they're designing a generative AI system, are going to think about these things. Obviously, then you've got humans in the loop. Okay, so humans still make the decision, but they're assisted by AI. And what's interesting to me about this is, for me, this is a huge area of improvement and possibility for generative AI. I don't believe that you have to replace humans to get a tremendous amount out of generative AI. I think that's a misnomer. I think that what generative AI is actually best at is doing all the things that humans really hate doing. So we should let them do that. That would be great. And then finally, you can have process design. And this process design involves understanding the limitations of the technology and being very intentional about what you do to make up for that. So hallucination checks, validations, whether by a human or by software, those are all extremely important. And I would actually encourage any of you, and we'll see this towards the end of the presentation as well, but if you are considering a generative AI solution for your business, especially if it's maybe a custom software design, and you get into understanding a solution, one of the reasonable questions you should ask is, what's your hallucination check process? And it shouldn't just be the human. It shouldn't just be somebody saying, well, you should check and make sure that it didn't make things up. No, there are a lot of ways that you can put a lot of trust into a system besides the human just having to check. How many people, this made headlines, so I imagine a lot of you have heard it, but how many people heard about that poor lawyer? I think he was over in California. He decided to use ChatGPT to create case precedent, and it turns out that it just made up a bunch of case precedent. Yeah, that was really dumb, but at the same time, he was one of the first to do it. So props to creativity. At the same time, he probably should have double-checked the things that he was getting. This is a pro tip. I would never, ever, ever rely purely on the internal knowledge of a model when you are expecting an answer. That's one of the designs that we'll talk through. Happy to talk about that afterwards as well. What that means is that if you have a specific task, you need to give it the data associated with that task, much like you would an intern. I think that the comparisons I've seen to treating ChatGPT, Claude, any of the models as a studious and helpful intern are really good. It's going to do exactly what you tell it to do sometimes, and it can get things really wrong other times. This is what we're going to talk about today specifically. We're not going to talk about the other two, although we will touch on how the other two impact the middle one. We're going to focus on the middle one. Okay, you'll see a lot of things about human in the loop. This is all I mean. Nothing more, nothing less, very broad. We want the humans to make the decisions in an AI system or with an AI-assisted system. So all we mean is humans are in the decision-making process. Also, this was true before generative AI. Traditional forms of AI still have human-in-the-loop concepts, just slightly different application. I asked ChatGPT to tell me what it would look like to have humans in the loop versus not in the loop, and this is what it came up with. There are some things here that actually make sense, but for the most part, this is what I would expect from ChatGPT. So think of humans in the loop as having a system that is powered by generative AI, and the human still has the ability, with levers, knobs, controls, to influence the output and change the output. Whereas, without having a human in the loop, you've got a black box. Now, that doesn't necessarily mean that you can't crack it and see what happened on the inside, but you put something in, you get something out, and everything in between is being made autonomously. And there are use cases for that. We'll talk about that. But for the most part, we're going to spend our time talking about the oversight and control. All right, guiding principles. These are the ones where we're going to try and get the context right for how should we think about using these models. And what's interesting to me about this is that we're talking about decision making here. And so a lot of the design principles that we're going to talk about are the same as if I had an employee that's making important decisions, and I want to know how they make those decisions, why they made those decisions, and to justify those decisions. So first and foremost, every decision that you let a generative AI make needs to be accompanied by a justification and needs to be verifiable. So what I mean by that is these are just design patterns. If you ask ChatGPT to give you an explanation of something, you can just say, give me an opinion. You can also say, give me an opinion, tell me why, and tell me where you got that opinion. And not only will you get better answers, but you can then go verify that, especially if it's using some statistics or internal knowledge. And you'd also be able to think about it yourself. See, do I agree, disagree? And at the very least, it's thought-provoking. At the very most, it allows you to make a much, much better justification for your use of the system. Second is about context. Now, there is the actual context window that you can give an AI model. That is what I'm talking about, but it's not quite what I'm talking about. So what I mean by that is you have a task that you're going to do with a generative AI system. The context you give it is all the data that it would need to reference when it's making that decision, when it's coming up with some task. So we're going to go through one example where there's a system that's called BidScore that allows autonomous grading of RFP responses based on a scoring rubric. So what the system does is you upload an RFP, it extracts the grading requirements from that RFP. You upload a submission, it reads the submission, and it applies the grading criteria to that submission, and it gives you a score. Now, it is explicitly instructed not to use any internal knowledge. So if the RFP is about, say it's a government contract for building missiles, well, somewhere, somehow, in one of these models, it has been fed information about past rocket systems or contracts or something like that. You kind of want it to avoid relying on its internal knowledge base. You would rather it explicitly reference what you give it, and you can do that. But that's what I mean by context, is the information you're giving it. You need to know exactly what was given to the model when it puts something out. That's important. And the last bullet is probably the most important. If you can't read it, especially since people are at the back, it's pointing back to the source material. So ideally, when you're getting decisions from a generative AI application, you would tell it, don't just tell me where you're getting this information, but I want you to cite it for me. I want you to tell me the page, the paragraph, the number, the document. And I don't know how many of you follow Anthropic. It's an amazing organization. Within their Claude model, they just released this as a built-in functionality. You can actually say, give me citations, and the model will actually, it's basically built-in RAG, but the model will actually give you back an answer, and it'll tell you, based on what you gave me, here's what I looked at to give you that answer. Very valuable when you're trying to double-check something. And then finally, user experience. So what I mean by this is if you have an application and it's designed to use generative AI, once again, I'm not talking about chatbots here, that system still needs to have the experience in mind. What is the process a human will do in using this system? Because if you forget the process and just try and throw technology at a problem, technology doesn't fix bad process. So it's really important to have a good foundational system that you can then enhance with AI. This is why so many of the advances in AI have, I think, resulted in really poor application experiences, because a lot of companies have seen, ooh, there needs to be AI, I need to put AI in my product, and they do, and it's not meant to go in your product. And so it actually ends up making the product worse. But you need to focus on enabling a good process, and I think this is extremely important, accuracy and consistency first design. Accuracy is a really big deal with generative AI. Once again, you can't just solve it by putting the temperature to 0 and moving on with your life. There has to be a very intentional design to the process and to how you use a model. And the user experience is a big, big part of that. We'll talk about specific examples of this. All right, so those are the principles. This is to get our mind right. Now these are some patterns, and these are patterns that we're going to walk through specific examples of these in applications, but these are ones that you can actually apply to the applications that you see and that you should expect from applications you interact with. The first one is verification first. Once again, think about this as human in the loop, so we are assuming that there's a human there, but verification first means that a human is going to confirm whatever you're getting from generative AI before something else is done with it. Okay, so most of the powerful systems out there have a step-by-step process that takes one input, does a lot of things, and does an output. And if you want to keep a human in the loop, especially for we'll say multi-step processes that are dependent, you really need to make sure that a verification is there before you do anything else with it. The second one is source-linked verification, meaning cite back the original source material. This is actually really on the humans designing a generative AI solution. Even though I mentioned that Anthropic does it out of the box, it still takes a user interface that is meant to show you what was cited, how it was cited, and make it easy for you to verify things. We'll look at one or two examples of that, but this is really on the designer of the system. And then finally, there should be a multi-stage verification approach. What I would recommend is that you have a verification that's done automatically first, something like a hallucination check, and then if necessary, if you don't have a high degree of confidence in your answer, you escalate it to a human. And depending on your process and how risk-averse your process needs to be, you may do that sooner or later. All right, so let's talk about the first one, verification first architecture. Pardon me for using my developer terms, because at heart I'm still a developer. But what I mean by this is when you start a task, AI is going to create content. That's all it ever does. You have large language models, you have vision models, multimodal inputs, but ultimately they're generating something. Generally text, because you can work with text. You can't really work with images much right now. But as soon as you create some content, you need to validate that content. And you need to validate that content before it's used again. This pattern would show that a human is doing it, but it doesn't necessarily have to be a human. It can be a generative AI model. Some examples of this would be extraction, data extraction. So if I give a generative AI model a PDF, and that PDF is image-based, it's not text-based, which means that if you were just to open it up on your machine, you can't click and drag and select the text. That is the bane of a lot of companies' existence right now. And you can actually read that using a lot of the models these days and extract the content. You used to have to do OCR with that. You're not really doing OCR with these models, but something similar. There are a lot of ways that programmatically you can verify what's on that page, right? I can look over the text and I can know, oh, is the subject matter correct? Is this an invoice? If it is, I should expect to see some sorts of terms on it. I should see numbers on it. All I'm getting at here is that as designers of solutions, there are a lot of deterministic or foolproof ways of going about designing a system. Always fall back to those whenever you can. It's a lot of times easier to do something with generative AI because you can just give it an input and it'll give you an output. But if you want to make sure that a system is highly accurate and sustainable and verifiable by a human, anytime you can do something programmatically, traditional software, you should. All right, when do you need this? When should you think about this? First and foremost, when you have a multi-step process. And I would actually recommend that if you're using generative AI, you examine whether or not you should have a multi-turn process regardless. And what I mean by that is there are a lot of ways to get really good, impressive results out of a single prompt. In fact, I think there have already been prompt engineering workshops here. Sounds like most of you are familiar with that. But I want you to think about how you interact with a chatbot typically. Because if I'm trying to generate content with a chatbot, most of the time on the first shot, it's not quite right. Right? I'm going to ask it, all right, can you make it a little more concise, or can you be more professional, or whatever, right? If I was drafting a letter. Well, you can build that into a system as a series or chain of prompts, and you get much more powerful results doing that. One of the reasons for that is the more specific you are with a task, the better it's going to be. No different than with a human. And so if you can intentionally design a system where every step has its own purpose, then you're going to get better results. But much like any multi-step system, if my very first step is wrong, then my last step is going to be wrong. And out of a 5-step system, if step number 3 is wrong, then 5 is going to be wrong, right? Because this is basically a logical chain of arguments, and it's going to build upon one another. So my recommendation here with this design pattern is, especially when you have a multi-step process, you need to be having verifications at each step in that process so that you can be sure that what you get at the end is not terrible. There is a saying, it's in software, it's in lots of things, gotta go garbage in, garbage out. When you have multiple in and outs, that only gets a lot worse. I think that mostly covers it, but I would add the last bullet and reinforce it, which is this is also extremely important when the outputs are more subjective than objective. And there are a lot of things like that generative AI can be used for, where it's difficult to really justify the decision, and it's difficult to know whether or not two people would give you the same answer or different answers. I'll go back to bid score. We will actually look at screenshots, and it's a good example of some of these design patterns. But if I give a human a copy of a submission, even with very good grading guidelines, two different humans will likely grade it differently. Maybe they'll come up with the same scores, but they'll have different justifications. They'll have different thoughts on why different things look and are perceived a different way. So once again, it's more subjective than objective. Okay, pattern 2, source-linked validation. This one is extremely important and I think should be table stakes for any application that is examining content, especially large amounts of content. You can think of 1,000 examples like this, but right now it's interesting to see that Google Drive, OneDrive, all of the big applications right now are building in features that are similar to ask me a question, right? I've got 1,000 files in here, ask me a question about that file. Well, what it's doing behind the scenes is it's taking your question, it's turning it into tokens, it's doing a semantic similarity lookup on its entire corpus of data, it's taking all the documents it found similar to that, and then it's saying, okay, based on this context, answer this person's question. Well, it has already done a lookup on what is most relevant, and it's given a bunch of context. Already have that data. It could just give you the answer, or like Perplexity or like Google is doing these days, it can give you the answer and also say, I read these pages, here are relevant sentences for you, here are the relevant documents for you, and oh, by the way, because I'm designing a software application and we can do these things, you can click any one of those and it will open that document and you can read it yourself. Much like a lawyer should do when they're looking at case law. Sometimes don't. So this is really important. I've got source material, I've identified the relevant material, I've processed all of it, and I get an answer. And ideally, the answer has the document and the pages, the document, the pages, document, pages, right? So it's a design pattern, and you should expect that from any generative AI. And I highly recommend that if you don't see that in a system, you just don't trust it, unless you're looking up random trivia or you're writing sonnets or something like that. That's fine. But other than that, definitely don't do it in the work environment. All right, when do you use this? Why is this important? So first and foremost, always do this when there is a known corpus of data. If I'm using a generative AI solution, it is interacting with a corpus of data, some knowledge base somewhere, you need to make sure that it does citations, period. And it's even more important for this when the relevant content can vary based on the question I give it, right? So if I've got 5 documents and I'm asking questions of those documents, chances are in my head, if I'm familiar with it, I can just know whether or not it's citing something real. But if I've got 1,000 or I'm browsing the web, then it could look up different content depending on the topic, the question, the task, and that's even more important to know. All right, second one, or last one that we're going to talk about today is multi-step verification. So we already talked about this a little bit, but this would be when you have a task, it produces something, and whatever it produces is just the first step in a chain of activities that produce an output. In this case, this is an example where maybe you have a task, something is generated, and first you actually do some validation with either the same model, another model, it doesn't really matter. You review that content and see whether or not you can verify it. And if you can verify it, great. You can probably move on. If you can't verify it, then there are a couple decisions you could make. You could retry it, see if you could then verify it, or you can escalate it to a human. Totally random, but how many of you have actually used the OpenAI's help chatbot? Okay, up until 2 days ago, so nobody raised their hand. You would think, as far as helpful chatbots go, it would be pretty good, right? At least that's what I thought 2 days ago when I first had a question about something that they were doing in their APIs, and we had a rogue API key. And my question was actually really, really simple and straightforward. I was shocked because OpenAI does not allow you to freely chat with their help chatbot. You can't just ask it a question. It does the typical chatbot thing with support that nobody likes that says, okay, how may I help you today? Click on one of these topics. Well, one of those topics was not what I needed. So I had to escalate to a human very, very quickly. I don't know. I expected more from OpenAI. I really did. You would think, hook it up to ChatGPT, it's good to go. No. So it escalated to a human really, really quickly, right? But there are a lot of other tasks that you can do checks on that drastically lower your rate of failure. And whether or not you're tracking your rate of failure in a AI-generated or AI-powered system is another question. I highly recommend that you do it. For the ones that we build, I can tell you what the hallucination rates are, and I can tell you how much they go down with certain patterns and techniques. But to give you an example, even if all I was to do inside a workflow, and I knew that that workflow had a 90% chance of being right, 10% hallucination rate, right? 10% hallucination rate is really bad. But 1 out of 10 times it's going to give me something that is just made up. But I build in a check. And I build in a check that all it does is it gets the answer, it gives whatever I gave it, and it says, does this make sense? It could be a binary question. Does this make sense? And if the answer is yes, move on. If the answer is no, well, then maybe I could just retry it. Because if I retry it, then I have another 1 out of 10 chance of getting a hallucination. But all of a sudden, my rates of hallucination in my system have gone dramatically down, right? So very, very simple design patterns. They can be extremely effective, and you get a much, much higher accuracy rate in your overall system. So we'll see some examples of this, but once again, there's a age-old saying, especially when you're working with highly important information, trust but verify. I would actually recommend you don't trust and you verify always with generative AI systems. Okay, so this is actually really important as a concept because when do you use this? Well, you use this when you have an evaluation metric for your system. And you should always have an evaluation. This is something that's being overlooked, but I think the industry is going to catch up to it, which is that when I use a generative AI solution, since often the results are more subjective than objective, there is a tendency not to put formal testing processes around it. For instance, a lot of companies, especially AI companies, will hesitate to tell you what their hallucination rate is, because you could bicker about what a hallucination is, and I could do that too. I get it, but you should know what that is for a system. You should also know, based on a predefined list of tests, whether or not your system is going to get it right or wrong X percentage of the time, and that's different than hallucinating. Hallucinating is just making something up. If it gets something wrong, that's different than making something up. And I put the second bullet just to drive home a point, which is just do it. There really isn't a scenario where you're building a generative AI solution where you shouldn't have some sort of verification process in it. And all the applications that you all have used, even if they're just chatbots, they have a tremendous amount of verification going on behind the scenes. They wouldn't call it verification, they would call it guardrails. But to avoid the system of putting something out that's either going to offend or be blatantly wrong or to be dangerous, and that is a form of these verifications. So always do it. Okay, I'm going to pause just for a second, but we're going to start talking about some case studies. And as we talk through the case studies, this will be a good point where I'd love for it to be a little bit more interactive. So I know we had a question at the very beginning, but as we go through these case studies, and I think we have 3, maybe 4, if you have questions about them or comments, please share, because these are practical examples that are in the wild today, and happy to talk about the guts of how they work and the design patterns around them, but they're examples of the design patterns we've already talked about. All right, we already talked about this one, but it's one that's, I think it's easy for everybody to understand, especially here in Huntsville, big government contracting presence. But BidScorer is a product where the use case is extremely simple and straightforward. I upload an RFP, it's going to look at that RFP, and it's going to create a grading criteria. It does it from the requirements in the RFP if they're there. If there is not a grading rubric, if you will, within the RFP, it'll create one for you. And the first thing that it does is it actually says, hey, human, I want you to verify what I just created. And you've got full control over it. You can go through and you can edit any category, any concept, and I think the slides are going to be sent out afterwards. But the other thing that it's going to do is after it takes these high-level categories, it's actually going to look at the RFP itself and pull out the requirements. So basically, based on this category, where in the RFP did I get it? What requirement from the RFP did I get it? And then it's going to create a grading guideline. The grading guideline is for two reasons. One, it's for you as the human who actually knows what they're doing to look at it and say, all right, this is how you're going to grade things. Do I agree with that? And it's a 1 out of 5 system, 1 through 5 system. So it'll tell you this is what a 1 should be, this is what a 5 should be. Do you agree with that? And you can edit it. The other thing, though, that it does is it provides a grading guideline for the humans who come in afterwards and look at the score that's given and agree with it or disagree with it. So it actually serves two purposes. So once again, you've got that verification step in there. The second thing, though, that it does is after those requirements are generated and verified, you have the ability at any time to open the RFP to where the citations came from and view the source material. So you can't see it, at least on the screen probably, but behind here, the requirements were generated and it says I cited this requirement from this page. And so you click on that, you get the page, right? So once again, you can cite the material, you can go to the source material very, very quickly. As a human, I didn't have to read the entire RFP. I can, and this is a very small RFP. This is a 12-page one. Biggest RFP I've seen is 960 pages. Who's seen one bigger than that? Oh, you poor man. But once again, 12 pages isn't a big deal. 960 or 1,000 is a big deal. This is a design pattern, right? And it's really, really important. The last thing, though, that I'll mention on this case study, and then I would like to open it up for questions, at least on this example, is what we call a hallucination check. So every submission that is uploaded, it is compared against every category within the grading criteria. And it's assigned a score. It's also assigned a justification. We then take that justification, the score, and all the context, give it back to a different model, and say, does this make sense? And we get back two things, actually. We get back a yes or a no, and we get a why. So you can actually look at both. But what the system does automatically is if you get back a no, it's going to regrade that. And if I get back a yes, then we have a log of it, but we treat that as valid, and the user can see it. If we get back 2 no's in a row, though, we escalate it to the user, and we say, hey, you need to look at this one because we couldn't verify it, and we're not confident that it's right. Now, at any point in time, any user can look at any justification, any score, and override it. But this is proactively raising that for them so that they can verify it. All right, with that, anybody have any questions about any of the patterns we've talked about so far and this example specifically? We've got, I think, 2 up here.
I had a couple questions. So first you mentioned extremely large request for proposals, say 900 pages, and I'm aware that some of these LLMs will have a context window, so I was wondering if their performance is degraded when they have an extremely large PDF like that.
Yeah, so question is, RFPs can get really large, and if something is 960 pages, then performance does go down when you get that large. And so there are a couple different ways that you can handle that, and what I would actually recommend if you're handling that. I actually think that the context question is going to become less relevant, but 960 pages is really, really large. I don't even think the Gemini models would be able to handle that with their million token context limit. A token is about, well, a word and tokens is about a 4:3 ratio, so you actually start getting up into the many thousands, hundreds of thousands to millions very quickly. So you would do what's called RAG. RAG is what's known as Retrieval Augmented Generation, RAG. And what that does is it does what I mentioned at the very beginning, which is a semantic lookup on any corpus of data. So you would actually first have to take that RFP, you would have to ingest it, and every page you would have to tokenize. These patterns are really, really established these days. They're getting commoditized, so there are a lot of services that'll do this for you. But first you would tokenize the entire document, and then you would have specific tasks run on that document so that you could fetch just the relevant pages. There are other patterns that you can do where you actually take segments of the RFP or the document as a whole and you summarize it. So maybe I take the first 50 pages and I summarize what those 50 pages had in it. And I'm very, very thorough in what I do there. Generative AI would be great for that. And then when you want to ask a question of that document, first you just look up which segment was it going to be in? Is it going to be in the first 50, second 50, all the way up? And then I can actually fetch the original source material, right? BidScore does actually use RAG when it's grading the submissions because we see that submissions can get way too large very, very quickly. And there are actually three things. Submissions can get too large to process in a single request. I would actually say that if you're dealing with probably more than, we're going to say, 10 to 20,000 tokens, and you can see this statistically. When you get to more than that, the hallucination rate, accuracy rate of all of these models goes down noticeably. We're talking if Claude can answer a question about a 200-page document with 99.9% accuracy, that's answering a single question. If you want it to generate a scorecard, so multiple pages of text perhaps, then you're going to go probably from we'll say, making up numbers here, 99% accuracy with, we'll say, 10 pages of text to, we'll say, between 50 and 75% accuracy when you start getting above 40 to 50 pages. So you need to do that anyway, but that's how you handle it, is you handle it with a combination of retrieval augmented generation, RAG, you'll see that in a lot of places, and you also handle it with combinations of summarization, chunking, but they're well documented patterns, but it's a very real thing. Like it's a very, very real thing.
Thank you, that was very helpful. And I also wanted to ask, you mentioned using another model to do your verification. Is that actually a different model as in 4.0 versus 0.1 or just a different instance of the same model?
Yeah, it's a good question. Either, it could be either. I actually would tell you, a lot of people, and I've been there, a lot of people will say, for purposes of accuracy, they like to be able to say something is checked by a different model. They like to be able to say that. But the fact of the matter is, if I do one request to any of these models over an API, and then I do another request, unless I've used the built-in tools that they've given me to reference that first request, there's no cross-pollination. If there was, they would have a huge problem on their hands for obvious data security reasons. So you can, the only time I would recommend exploring that is if you have fine-tuned a model to be really good at the verifications, which is actually an extremely good use case for fine-tuning a model. Fine-tuning a model is when you take a base model, you give it a bunch of examples of exactly how you want it to behave, and it gets really good at behaving that way. So for instance, if I wanted to have a hallucination checker model, then I can go to OpenAI, I can fine-tune GPT-4o or 4o mini, and I can give it 50 examples. And those examples are just me saying, given this content, is this a hallucination or not? And I give it the correct answer. And it'll get really good at doing that. Now, there are things to keep in mind. With traditional ML, you can over-rotate on specific examples, but that's a really good example of doing that. If you're not doing that, then use any model, use good prompting, and you're probably going to be fine. Next one is, this is a contract extraction module, and we're going to see a lot of the same design patterns here, but what this particular agent does is it'll take a contract, and typically that contract is between 10 and 50 pages. We've seen bigger, we've seen smaller, but typically 10 to 50 pages. And what it's meant to do is extract about 30 consistent data points from those contracts. They are contracts like you would see every day, where every vendor has their own format, every vendor has their own terms, and there's very little consistency between any of them other than what you would expect those contracts to have. So the contract will have a defined term, it will have a defined amount, it will have a point of contact, it will have an expiration date, right? But all of those will be called something slightly different. All of them will be in different formats or pages, and so generative AI is a great solution for this. Historically, these types of natural language processing problems are really difficult for just software to solve. Whether or not this word, like my company name, whether or not GenServe Co. is the same as GenServe Company, is historically a very difficult problem in software where I don't have a finite number of options. I don't know what another company is going to call this thing. Generative AI is really good at that. And so this is a big efficiency gain where somebody can upload a contract, get back the 30 data points, and then they can do the things that we've already discussed, which is, okay, I found this term, it's on this page, and I can click on that to go to that page and find it, right? So immediately I can understand where to find it and how to validate it. This one is particularly important, though, for verification, because the multi-step process here is to extract the information and then eventually put it inside a knowledge base, where I'm going to run reporting off of it, I'm going to have business analytics off of it, and it needs to be right. And so for this particular use case, before somebody hits that button to put it as part of their knowledge base, it has to be verified, and it has to be verified by a human. This is one of those cases where you would not want the verification to solely be done on the part of the software, though there are ways for you to do it. So you have two different things happening here, right? The data extraction and the validation, but similar patterns, right? And you're going to see a lot of similar patterns because the data inputs are going to be similar. Typically, you're dealing with text, or you're dealing with a representation of text, and a lot of document formats are similar in that sense. All right, this one's a little bit different. So this is a company called Astound Research. And what Astound Research does is it matches academic researchers to the funding opportunities that match up with their areas of expertise. So if I'm a PhD over at UAH and I study biochemical engineering as it relates to the spread of cancer or something, I'm making stuff up. I have no idea what I'm talking about. But if I do those things, then Astound Research will let me upload my CV or resume or whatever it is. It will extract all the relevant information from it, and then it will match me to the funding opportunities on their platform. They maintain, 1,000, 2,000 different funding opportunities, and what they do is they have defined themselves a common language for what keywords, topics, and areas of interest are between what you would expect to see from a CV and what you would expect to see in a funding opportunity. And so the first thing it does is it extracts those automatically. After it extracts those automatically, you kind of get rid of the generative AI magic, because then there are more tried and true ways of saying, what's the overlap here? Of the keywords on this profile versus this funding plan, what matches do I see? And it will automatically rank those. Now, this is a multi-step process, because the first thing that actually happens is constructing a profile. And that's not just pulling out keywords, that's understanding from their current position, from their past research, from their current experience, what is the overall landscape of this person's interests and how do they apply to scientific terms. And they have the ability to edit that at any time, and also the team at Astound has the ability to edit that at any time. So they may see some specific keywords and think, you know what, that's true, but because they're in this area, I know that they're also a good fit for this one, and they may add a few, or they may take some away. But either way, you've got the human there who's actually making the decision. And then on the side of the funding opportunities, you have a similar thing, because when a government entity or somebody else puts out a research grant, I've seen some that are as detailed as a 50-page document, and I've seen others that are a paragraph. I'm sure many of you have seen similar things. And so it's very difficult to know, based on the content exclusively within the funding opportunity, who would be best to pursue it. And so they have a corpus of about 1,000 of them, so they've developed patterns to know, based on this type of research, what are keywords, what are areas of interest, what are topics that make sense that may not be explicitly in it, but related to it. And so it extracts those first, and then it does a comparison. At any point in time, you can check the source on any of this. You know exactly what was sent, you know exactly what was brought back. There is perfect visibility, but it is much like a human would do. It's just a lot faster for a machine to read a 30-page CV with experience and research papers than it is for a person to do that. And then obviously the matches are ranked and you would see them. But this is actually a good example of where, to the users of the system, the fact that it's using generative AI is not very apparent. And I would say that's good. Typically technology fades with good design. You don't see it as much. Bad design is where you have technology staring you in the face. Because as a user of these systems, I have a task. I want to do this task. Anything that makes me faster at the task is good. Anything that makes me slower is not good. And this is a good example of that. There is one last topic that I think is important, which is, when do you not need a human in the loop? Because I think that's a really fair question, and I won't be the one to tell you that you always need to. You actually don't have a lot of... You have a lot of examples where it kind of defeats the purpose if a human has to look at every example, right? Well, the first one is, if you can statistically show that you have a certain level of accuracy and your risk profile is acceptable with that degree of accuracy, go for it. But you need to be able to know what that level of accuracy is. I can extract contract terms with a level of 99.5% accuracy. And for that 0.5%, I have a human looking at it who can verify it immediately. So that's totally acceptable, and that makes me faster, and I'm good with that. And I would actually tell you that there are a ton of use cases for generative AI that can get to close to 100% accuracy rate. And you should identify those and go for it. I can also typically at this point, and you can find lots of examples of this online, hear a scenario and tell you with a fair degree of confidence whether or not you'll have a high or low accuracy rate with that and generative AI. Some are well suited, some are less well suited. I can tell you just a couple rules of thumb, where the more content you are processing, as was brought up earlier, the less consistency you're going to get. Prompting aside, don't care what your prompt looks like, don't care what your temperature looks like. The more content you are processing, the more variability you will get in your answer. And because there's just built-in variability, the less accuracy you will likely get. So you just need to be aware of those types of things. What's the impact of it being wrong, right? I mean, this should go without saying, but I like saying it because it's important. If you have a system that is just a nice to have, and if it gets it wrong, that's okay. Then go for it. Like, there's no reason to introduce a lot of friction into the process, but you especially need to think about downstream systems, not just input, output, I'm reading an answer, I see the answer, but is this going somewhere else, and is this going to be an input for another system? Two more. One is auditability. It's less important to have a human in the loop at every step if you've built your system such that every step you can know exactly what happened during that step and why. Because then even if a decision was made and it was wrong, or an output was wrong down the line, I can always go back and look at why it happened, right? And you have to take this in the context of the first two, right? Because it's not okay to say why something was wrong if you are bankrupting your system after that happens. And I say that because an example of this is happening right now with a lot of companies who are pursuing autonomous developers. So a lot of companies out there, I think Devon was one of them that made headways, that is an autonomous developer, right? It'll write code for you, it'll check it in, it'll do all this great stuff until it starts pushing a petabyte of data to Google Cloud and you get a $470,000 Google Cloud bill. True story. Not to me, somebody else, but true story. They know exactly why that happened. And they never would have imagined that that could be a problem. There were a lot of things that had to fail for that to happen, but be aware of it. And then volume, right? There are some tasks where you want to automate it because a human cannot literally do it. It's happening thousands of times a day, and so you cannot have a human verifying every step. But you could do sampling. You can have a human verify every other step or every 500th, or you should absolutely have built-in checks at this point in time and start understanding error rates. So, these are all things to keep in mind. The point here is that humans are not always meant to be at every step in the process, but you could actually argue that many of these could have versions of humans in the loop that still allow something to run basically autonomously. You still get all the benefits from it, but you don't have the time of a human just looking over the shoulder of an AI system. And ultimately you're getting a lot of the same benefits from it. So, some things to keep in mind there. But with that, I would love to open it up to questions in general.
You said source link validation in your slides, but you said verification. Do you distinguish between the two?
Yeah, that's a good question. The question is, pattern number 2 is source linked validation. I said verification. I don't know that I would distinguish between the two. I think the point there is the source linked material helps you validate whatever it is that you're saying, right? So I don't know that I would actually use the two terms. I probably did it on the slides because I didn't want to have verification on 2 different patterns as a word. I don't know if you have an opinion on that, but the point there is this: a human needs to be able to validate it, verify it, and they need to be able to go back to the source material when they do that.
Well, my background is systems engineering, and there will be fist fights over the...
And they probably will be, yeah, that's fair. That's fair. Other questions?
When you're talking about black boxes, what about AI accountability? Like tools like Captain, have you used that for accountability and verification?
I actually have not used Captain, but I'm curious, when you say AI accountability, what do you mean by that?
I mean, AI explainability. Explainable AI, basically.
Okay, so a couple thoughts. One, the point of human in the loop for me is to make sure that a human is always accountable for a system decision. And ultimately, a human will be in a company, whether they knew it or not. And if you don't designate a responsible party for a specific problem, then it's going to fall on somebody when something goes wrong. So I would always say that a human needs to be accountable for it. It's much like a software engineer creating a bug, and after something goes wrong because of it, they just say, it was the code that did it, right? It doesn't really work. In terms of explainability, one of the design patterns that we had here that I would always recommend is having a justification for decisions made. And that is basically what I would have as the equivalent of the accountability for the system. A lot of tasks are going to require it. You basically can't use, you can't use a system that does RFPs, for instance, in any sort of government contracting unless there is a reason or a justification for a decision made. So it's kind of table stakes. But I would argue it should always be table stakes. I would also argue that you will get better answers from any of these generative AI models if you ask it to give you a justification for its answer. And I'll give you an example. And this is actually not widely known, but how many of you interact with Claude? Okay, so Claude is Anthropic's version of a chatbot. I use it more than ChatGPT. I think it's better. But Claude and Anthropic have an interesting design pattern with their tools. where behind the scenes, if you ever look at their system prompt, when it gives you an answer, behind the scenes, it's actually giving you two things. It actually says, hey, I want you to think out loud first and put that text in thinking tags. And that's basically the justification for the answer it's giving you. It doesn't show that to the user because it gives you two things. It says, give me this, it's going to be in thinking tags, and then give me an answer. And it shows the user what's in the answer. Behind the scenes, Anthropic has every single one of those logs, which is why, unless you have an exclusive agreement with OpenAI or Anthropic and you have a very narrow set of use cases, they will always keep your logs for 30 days, at least. You can get a zero retention policy with them, but it's an exception. So, long story short, I would always recommend having a justification for a decision made, unless it's just so simple that it doesn't provide any value. But to the accountability, I would just say that a human always has to be accountable for a decision made, and it always helps if it can say, well, this is what one of our models said based on the source material given. So.
All right, so as a developer, how do you approach new models that keep coming out? And what's your decision at the top to make a switch? Because token costs are coming down with new models that are coming out, especially DeepSeek. It seems to be all everybody wants to talk about right now. So as a developer, how would you use, what are your evaluation metrics to say, okay, it's time to switch to a new model?
Yeah, that's a really good question. So a few thoughts. Internally, and so for my company, for instance, for GenServe, we have a set of probably 10 benchmarks that we run against models, and we actually run it against it pretty consistently because I hear from, for instance, the Anthropic CEO that they don't change their models, but it sure does seem like they change the models often, right? And I can actually point statistically at tests that passed during 1 week and they don't pass them anyway. So we have benchmarks that we run. And what's interesting to me is, for the most part, the use cases that we identify are solvable with current models. So it's not like we need newer and better models for most use cases. At that point, it becomes a business scenario where do I need to have better unit economics on it, or does it need to be faster, or something else, right? And so there are a set of use cases that would get a lot easier with better models, but not necessarily unlock anything. There are a few very specific use cases that I'm still waiting on that would be great if models could do better. So far, none of them have been able to crack it. To be honest, from the last model that I've seen come out that scored, we'll say, noticeably better on our benchmarks is Gemini 2 Flash. When that one came out, it performs better than Claude Sonnet 3.5, GPT-4o. O1 I don't put in the same, O1 or O3 I don't put in the same category. Aside from cost, they're just kind of meant for different things. So to not answer your question, we do have benchmarks. So we evaluate every new model against those benchmarks. But for the most part, unless it comes with a substantially different price tag or capability tag, we're probably not going to change any of our production solutions because the risk is just too high. There's just no reason for us to do it.
So you got a set of gold standards that you're continually going against of your own use case.
Yes. Yeah. So what he just said is we have a set of standards, and we evaluate every new model against those standards. And we are actually having to come up with harder benchmarks for them because most of the top models these days will pass most of them most of the time. The top 3 models, Gemini 2.0 Flash, Claude Sonnet 3.5, and GPT-4o, will pass the top benchmarks all of the time within a good week, we'll say. I only say that because 99% of the time they will all pass. Random days, they will fail. And you have to be aware of that type of thing. So, other questions?
Hey, I'm on the government side of government contracting. Cradle to grave, contract administration activities, requirement definition, solicitation development, proposal evaluation. Trying to convince the powers that be to allow us to use some tools that we're not currently allowed to use at my specific agency. Any advice on how to navigate that? some of the things we create are posted on sam.gov, a publicly available website anyway, so it's kind of a timing thing for permissions in some cases, but just any advice you have on navigating that?
Well, I don't know if you saw, but I think yesterday or the day before, OpenAI just announced that they've been approved for GovCloud in Azure. So I expect that that's going to change very, very quickly. OpenAI is very closely partnered with Microsoft, and the government is for the most part a Microsoft shop. So I expect that to be the fastest adoption. At the same time, there are actually several AWS Bedrock models that are also approved for GovCloud. So you can deploy those. I think that the regions are limited, but I know that 1 or 2 are approved for US West 1 and US East 1. So there are options, and they are approved. So I would suggest going with those and follow the official approvals because they are coming. And the interesting thing about it is I actually went to demo at a government agency here on the Arsenal a year ago, 6 months ago. None of them were approved. And so it changed that quickly. So I expect that it'll get easier. I do. I do not expect the applications that use them to be that quick. I think that the fastest adoption you'll see are likely the Copilot products, the OneDrive products, the Microsoft baked in things. And so I guess my recommendation would be to try and explore kind of the commoditized sets of functionality. For instance, just with having what's called a RAG pipeline, you can build a tremendous number of applications. And so if all you could do was get a single model, and 4.0 would be plenty, and a RAG pipeline, you'd be able to build 90% of the applications that are AI powered. That'd be a great starting point.